Hello Blender enthusiasts. In this video I'm going to show you how to control a Blender character object and a Blender rigid body object with an Xbox 360 controller. The first half of this video will show you how to set everything up inside of Blender. In the second half I will go through the scripts and explain how everything works. I'm starting from a new file, but you can apply what I do to an existing game. Make sure you're in the Blender game engine, then rename your character to player. Next, give the game character your desired physics and enable collision bounds. Then create a surface for your character to move across. Keep the physics type as static and enable collision bounds. Now apply a material to your character. The settings you use are optional. I use a small emit value to make my materials easy to see. I give my character a second material, which I apply to the face inside of edit mode. This is so I can verify that my character is moving in the right direction. Next, apply a material to your ground object. Again, I use a small emit value. I also give my ground object a distinct name. Now it is time to import the script. Create a new window by dragging the shaded part of the top right corner to the left. Set this window to the text editor and enable line numbers and text highlighting. The link in the description will take you to my GitHub page. Choose the correct script for your character and then select and copy all of the text. Back inside of Blender, create a new text document and call it either character.py or rigidbody.py. I will start with the Rigidbody script. Paste the text you copied into this text document. The script will now have to be set up. This involves creating some logic bricks. Increase the size of the timeline window at the bottom and change it to the logic editor. Create two joystick sensor logic bricks. Name the first one axis and the second one butt. Inside of axis, enable true pulse triggering. Then set the event type to axis and enable all events. Then inside of butt, enable tap triggering. Set the event type to button and enable all events. Now create a Python controller logic brick and set it to the script you have chosen. Then connect the two joystick sensors to the Python controller. The logic bricks are now set up. Here I do some last minute scene setup. I change the view mode to textured, then create a new hemi lamp to better see my character's face. If you're using the Rigidbody script, this is all you need to do, and you can press P to begin testing the game. If everything works, you should be able to control your character's movement with the left thumbstick, be able to rotate your character with the right thumbstick, and make your character jump with the A button. If you're using the character script, there is an extra step you must take. In order for your character to move in the direction it is facing, you must rotate your character by 180 degrees along the x-axis. Select your character and then tap R. Then type 180 and then press enter. To prevent your character from being upside down, you need to apply the rotation. This is done by holding Ctrl and then pressing A. Now simply rotate your character by 180 degrees along the x-axis again. If everything has worked, you should be able to control your character with your Xbox controller. The rest of the video is me talking about the scripts and explaining how they work. So if you are only interested in how to set the scripts up, feel free to stop watching. Hello Blender enthusiasts. Welcome back to part 2 of the Xbox controller setup video. This is the part of the video where I will go through the script and explain how everything works. As the scripts are very similar, I will only show both of them when there are differences. Let's begin with the first part of the script. This block of text finds out which operating system the script is being run from. The variable OS is declared as a string and is set to the value of Windows. The function platform is then imported from the system module. Platform is the operating system the computer is running. A test is then conducted using platform. If platform is not equal to Windows, then the variable OS is set to the value of Linux. The function on Windows is then defined. This function returns positive if the variable OS is directly equal to Windows. So to recap, our variable OS is initially set to Windows. If platform is not equal to Windows, then the OS variable is changed to Linux. Our function on Windows is then run and will return positive if OS has remained as Windows. If not, it will return negative. Next, the Blender Game Engine and the Blender Game Logic modules are imported. This allows special Blender game functionality to be used in the script. The variables reduction and axis threshold are then declared. Reduction will be used to lower the output values from the Xbox controller. This is needed because these values are very high, and they will be used to directly manipulate the game character. Axis threshold is the lowest value the Xbox controller can output and still trigger an event. This value will be used as a cutoff to stop the character from moving when there is no input from the Xbox controller. Next, the variables controller and object are defined. Controller is the code for the Python controller logic brick this script is run from. This will be used to reference connected sensor logic bricks. Object is used to call objects in the current scene. Objects that have been called will be able to be manipulated by the script. These variables are used to reduce repetition, and mean these functions are only called once, reducing memory usage. The character script has an additional variable called character. This variable is used to call character type objects in the game. Next up are another pair of variables, axis and button. These are the two joystick sensor logic bricks connected to the Python controller logic brick. These take the output from the Xbox controller and pass it to the script. This next part of the script is what gets the output from the Xbox controller. The variable ONW calls the function on Windows. This is used to change the values of the buttons and axes on the Xbox controller depending on which operating system the script is run on. This is done because the values of the buttons and axes on the Xbox controller are different on Windows than they are on Linux. The test works like this. A button or an axis is equal to the Windows value if the operating system is Windows. If the operating system is not Windows, the value of the axis or button is equal to the Linux value. These are the 6 axes on the Xbox controller. These axes are left and right on the left thumbstick, up and down on the left thumbstick, left trigger, left and right on the right thumbstick, and up and down on the right thumbstick. These are the 15 buttons on the Xbox controller. These buttons are the A button, the B button, the X button, the Y button, left bumper, right bumper, the back button, the start button, the Xbox button, the left thumbstick pressed, the right thumbstick pressed, left on the D-pad, right on the D-pad, up on the D-pad, and down on the D-pad. This next block of text gets the output from selected buttons and axes. Axis output value is obtained by calling an axis joystick sensor and using the axis values function with a selected axis. This value is then divided by the reduction variable. Button values are obtained by calling a button joystick sensor and using the getButtonStatus function with a selected button. Buttons return either positive or negative and therefore do not need to be reduced. Next, the variable play object is defined. This uses the object function to select the game object player. This will be used to manipulate the player game object. The character script has an additional variable called play. This variable uses the character function to select the character object player. Both these variables select the same game object, but they select them as different game types. This is done because character physics objects are controlled with different functions. Here the character script has some additional variables that the Rigidbody script does not. The variable play orientation is assigned to the value of the play object's local orientation. An object's orientation is the direction it is facing along the X, Y, and Z axes. This will be used to move the character object in the direction it is facing. Orientation is a matrix made up of 3 lists. The first list is the X-axis, the second is the Y-axis, and the third is the Z-axis. The variable X-axis is assigned to the value 0. 0 is the first list in the matrix. The Y-axis variable is assigned to 1, which is the second list in the matrix. Next are the variables that determine the speed and direction an object is moving in. These variables are different on each of the scripts. I will start with the character script. Forward-backward is the speed the character moves when going forward or when going backwards. It works by taking the values from the left thumbstick when it's moved up or when it's moved down and multiplies it by the player's orientation along the X-axis. This is what allows the character to move in the direction it is facing. As I stated earlier in the video, this method only works when the object is rotated by 180 degrees along the X-axis. This is because the object's orientation and the way it is facing are opposite to each other along the X-axis. The next variable, left-right, takes the reverse output value from left and right on the left thumbstick and multiplies it by the player's orientation along the Y-axis. This will be used to allow the character to strafe left or right. The next variable, facing, is a list which goes in the order of X, Y, and Z. The Z value has been assigned to the output value of left and right on the right thumbstick. This variable will be used to change the direction the character is facing. The final variable, stop moving, is the same type of list as facing. The values of this variable are all set to 0. This is because this variable will be used to stop the character from moving when there is no output from the controller. Next, I will cover the Rigidbody script. The variable motion is used to move the character forward and backwards and left and right. The X-axis is set to the output value from up and down on the left thumbstick. This will be used to move the character forward and backwards. The Y-axis is set to the output value from left and right on the left thumbstick. This will be used to move the character left and right. The variable facing is the same as it is in the character script. The difference is that the output from left and right on the right thumbstick is reversed to account for the fact that the object is not rotated. The final variable, jump, is another list with the Z-axis set to the value of 0.1. This will be used to make the character jump. Next, the function cutoff is defined. The function returns positive if there is no output from the Xbox controller. Output is determined by the state or value of the axes or buttons. Axes are checked by seeing whether their absolute output value is less than the axis threshold. The absolute value is used because axes can have a positive or negative output. Buttons are checked by seeing whether they have a negative state. Next are 3 functions that determine the character movement, the character rotation, and the character jumping. These functions differ slightly between the 2 scripts. I will start with the character script. The first function is called character movement. If the absolute output value from up and down on the left thumbstick is greater than the axis threshold, the character will apply the walk direction forward and backward. Else, if the absolute output value from left and right on the left thumbstick is greater than the axis threshold, the character will apply the walk direction left-right. The walk direction function is what is used to move character physics type objects. In the Rigidbody script, this function is called movement. If the absolute output value from left and right on the left thumbstick or up and down on the left thumbstick is greater than axis threshold, then the apply movement function will be applied to the play object with the motion variable speed and will be a local movement. Local movement means that the X and Y axes will be determined from the character's orientation and not the world's orientation. The next function is called rotation. This function is the same in both scripts. If the absolute output value from left and right on the right thumbstick is greater than axis threshold, then the apply rotation function will be applied to the play object with the speed and motion of the facing variable and will be local rotation. The final function is called jumping. This is slightly different on each of the scripts, and I will start with the character script. If the state of the A button is positive, then the jump function will be applied to the character object. The jump function applies the jump force in the character physics tab to the selected character object. Over in the Rigidbody script, the function works like this. If the state of the A button is positive, then the apply movement function will be applied to the play object with the speed and direction of the jump variable and will be global movement. Finally, the last function, main, is defined. This function is responsible for executing all the other functions in the script. It is slightly different in each of the scripts, and I will start with the character script. If the cutoff function is positive, then the walk direction function will be applied to the play character with the value of stop moving. So if there is no output from the Xbox controller, a 0 movement will be applied to the character. Else, if there is input from the Xbox controller, then the character movement, rotation, and jumping functions will be applied. This is how it works in the Rigidbody script. If the cutoff function is positive, then the script will be ended. Else, if there is input from the Xbox controller, then the movement, rotation, and jumping functions will be applied. Finally, the main function is run. That concludes this video. Hopefully you found this helpful and learned a bit about Python. If there's something you're confused about, let me know in the comments section and I'll do my best to help you out. Thank you for watching.